Okay, our presenter now is Matt Rhodes from MathWorks.
Yes, I'm morning. Good morning. Let everybody sit down for a second here. So I'm Matt Rhodes. I'm an application engineer for MathWorks. Mostly I help our customers with V&V needs, verification, validation needs, certification, qualification, with a heavy, deep focus in our polyspace tools. Just out of curiosity, who in here is familiar with or has used polyspace before? Anybody? All right, cool, good. I know some of you have for sure, but anyway, I come in today with a little bit of a different lens on an old topic. I do have the benefit of being across multiple industries, with most of my customers dealing with safe and secure systems that have high criticality needs for them. But like I said, this is not working. Hold on. Oh, there we go. Okay. Just slow. Nope. Lagged. All right. So this is a bit of a thought piece, an old topic with a new lens, just to have people think about things a little bit differently. A lot of it you'll say, well, yeah, duh, but hopefully you get a little more out of it than that too. I hope. So what exactly is apperception? Unless you have a background in psychology or etymology or some of these other interesting topics, you probably haven't heard this term before. So just a more non-psychology friendly definition for you. To comprehend a new idea by assimilation of the sum of one's previous knowledge and experience. All right? Makes sense, right? So, you're probably familiar with the Rorschach ink blots. How else can you make something like this without having that kind of ability, right? So everybody in here, I'm guessing you're all looking at this and saying that's a satellite, right? Yeah. So, now, engineering by nature is an apperceptive practice. And so I don't want you to think this is a new thing. I don't think we need to make this a term. It's just a way to think about and a lens to look at what you do every day. And what I really want you to take away from this is that this is something that is done as a collective, not just an individual person like that first definition might show you otherwise. So, last year, or not 2 years ago, at APL in Maryland, Aussie actually presented on the topics of MBD with systems and software engineers working together about collaborating, combining the domain expertise together. So building a little bit on top of that. And what it's really all about is taking that, the body of experience that we have, accumulating that knowledge to build the systems that we have to build, use them the way we have to use them, and put that together for the new ideas that we want to, what are we going to accomplish next, and then putting those into practice and starting over again, right? It's a bit of a, engineers are a lot like Sisyphus in terms of, pushing that boulder up the mountain all the time. But we like it. It's fun. So I wanted to give you some examples in the space industry in particular, but I do have some examples from outside of the space industry as well, worked in here. And so first and foremost, this flight software workshop is a great example of what I mean by apperceptive engineering, right? So, we're here to share our knowledge and communicate it across everybody. In fact, the web page actually calls out that is the purpose of this. Sharing the architectures and novel approaches and everything else we've done, so that we can take that practice and experience and disseminate it to the whole community. All right, now some of the less exciting things, processes and standards. So we have NPR 7150.2 that everybody's very familiar with. So do we have any of the authors of that in this room here right now? They were here earlier. I guess they're gone now, but I got it. Okay. Anyway, so you got the little blue books if you haven't seen it before or got a chance to dive into it. The ESA equivalent standard on here. A lot of you have probably referenced D178. All these things are here, and they're there to convey the knowledge of how to do the things the right way, the way you're supposed to do it. And I'm calling out SOTIF here from the automotive at the bottom. Not just because, by the way, safety of the intended function. I'll reiterate this later, but that's actually been pulled out of the earlier stages of ISO 26262 purely because some of the problems we're dealing with, the hot dog or not problem that was mentioned before, with machine learning, is it doing what it's supposed to be doing? And so they have a whole breakout standard now just dealing with that subject in the automotive space. It came out this year, so in case you need some help trying to figure out how you're gonna deal with your machine learning, it might be worth looking at that topic. On the security side, NPR 7150.2 also has some section on security. We're gonna have a whole section today. I'm not gonna go too far into that. Great talk from Dr. Oakley yesterday. I really appreciated the giant fear, uncertainty, doubt pill that he gave everybody here. It was needed. If you have to deploy on a DoD network, there's DISA-STIG. There's a giant checklist of things you got to deal with for making sure your systems are secure. I've heard a lot of reference to the RMF, which is something that most federal organizations have had to comply with since 2010, I believe. But there's also this NIST cybersecurity framework. It's voluntary, unfortunately, but it is there since 2014, and it actually can be used in conjunction with the RMF. So, but it is there for people who need that extra help. So, I actually have this diagram coming up here from another talk on cybersecurity. But I thought it was fun because it speaks to the process and standards and how we manage those as well as we go through them. So, everything we do in terms of process standards has things built on top of those standards. For instance, from a cybersecurity perspective, on top of the standard itself is you have a lot of risk management and known threat issues to look at and analyze as you design and build your system. What are the countermeasures that you need to put into your system to deal with the threats that have the highest likelihood and largest impact in your system, right? On top of that, we have the benefit of these tools we call databases, CWEs and KPEC, if you're familiar with common attack pattern and enumeration classification from MITRE. There's a whole database of known. That's a work in progress. Known threats and weaknesses though from that. Sorry, KPEC's down a level. CWE is the known weaknesses up on this next level up here, if you're familiar with that one. And at the pinnacle of that a lot of the commercial standards, D178 and ISO are dealing with already. Formal methods, they have sections in their documents speaking to how you can use formal methods to make your process easier. Okay, and a reason they do that is because, in effect, they are process countermeasures. They're added in so that you can reduce some of the issues you might have with process countermeasure issues or process risk issues. All right. So all that is to say that the top half of that pyramid is effectively referencing all the different tools we use in conjunction with our processes. And the tools we use, we go beyond that. There's lots of information conveyed And something as simple as Git, for instance. Chris gave a great talk on his Nugget program the other day that seemed pretty simple in terms of what it was trying to solve, but that actually conveys an awful lot about how we build and design system because of how that tool gets used, right? How we're trying to go for that mono repository with the submodules that can be reused as components and so on and so forth. There's a lot contained in the information available from those tools. Now, I can't stand up here for MathWorks and not talk about our own tools. So, we have a lot of them. That's just a snapshot of our web page there that lists all of our tools. I broke it down. This first column is all about stuff for the language of technical computing, the MATLAB stuff. And we have all the Simulink stuff in the middle for model-based design. And we've got our static analysis up in the top there, and services. But then at the bottom, we've got all these specific application products that are to do with subject matter expertise contained in the products that are at your fingertips. And that actually is one of my favorite quotes from a customer I was working with out in Utah. Said this, that he loves the tools because they represent the democratization of engineering knowledge. I was just talking with Joel outside in the hallway before this, and realized that it's more than that too, though, because we employ a lot of the subject matter experts at MathWorks, and all that knowledge from their time at various companies, like all the companies that have done everything from automotive to medical devices to communication systems, etc. And we have all that in house, plus all the experience working with you guys in other domains. So when I go help a customer with a problem and I start seeing all these different patterns for things that emerge, that I can come back and help other customers that have those same problems, right? So that's just another example of having the ability to disseminate that knowledge across all those teams. And really, I mean, just stepping back to the process point of view for a second, so many people I talk to, they come to me with the idea of, hey, I've got this checklist of things I have to do. And there's not a lot of thought that goes into why they're doing it necessarily, right? Oh, I have to do this, it's on the checklist. Not everybody, but I get that a lot. And I think it's very valuable to just take a step back and think about why we're doing these things, why they're on the checklist. I actually appreciate in the NPR, they have all the little notes in there, you'll notice, that try and give a little bit of the rationale and expectations for why those things are there as well in some cases. So that's a nice thing. I would like, they're not in here, but I'd like them to do more of those. Aussie put this together previously as well. It's a view of the V with some of our tools mapped over it, just to give you a quick idea. System modeling and the ability to prototype and do trade studies and that kind of thing is pretty quick and easy. We have all there's a space poster actually for how to map all of our tools to NPR 7150.2 available on the website. Or you can talk to Aussie, he can tell you more about it. You get into how you actually design your subsystems, and there's patterns in how you model that influence how you convey knowledge as well, right? So how you package your interfaces and things like that in the subsystem designs, simply choosing to use a model reference or not makes a big difference. Little things as you go along. Yeah, so there's a lot of hardware in the loop capabilities and things that would be great to test to make sure this didn't have lag in it. The code generation, so you can have a more consistent process as you go along, so that you can focus on the domain knowledge instead of worrying about the details of how it's coded on a regular, frequent basis. For those of you who have to do FPGAs or other ways of generating the end product, we have HDL verification as well to handle for the FPGA systems, and a whole testing framework available for going through all the systems that way, for your verification processes as well, so you can make sure you've met all of your requirements along the way. And Aussie could probably tell you more about this, but there's some mission planning and operations capabilities as well in the end. There's a lot there. I'm not going to bore you with all of that. The Other aspect of that comes up a lot is reuse, and this is kind of a meta topic that spreads through all of what we just talked about. I mean, the tools themselves are, in a sense, a way of having reuse, but there's also a lot of the concepts that we deploy as we go through reuse all the time. And one of the key highlights of this workshop is talking about the different frameworks we use for flight software and guidance and things like that. So, I mentioned the Git submodules already from Chris's talk. That was fun. Just using model references or other patterns of the system variants and things like that are really popular. Actually, something that I like to point out from our automotive customers, they have a lot of interesting ways of doing R&D where they actually communicate their system needs from the R&D groups, doing the V&V at a high level, the generic level, passing that on to the platform integrators. Passing the battery system on and having the having them take their calibration data, their operational scenarios effectively, and make sure that they still apply and go through the V&V with what they already know should be happening, and they can use that as a means of communicating back to the R&D team if they need to make changes. So it's actually a huge efficiency gain that they use for the commercial space, doing it that way. And of course, I can't not talk about the progression we've had for reusable space vehicles along the way. It's the reusable launch vehicles evolving, everything from the shuttle onward. One of the big things about reuse, well, there's two aspects. On the safety perspective, we get to make sure that it's safer and safer each time. But then there's the other side of that, the security aspect. And as Dr. Oakley was talking about, the familiar makes it easier for him. Right? So it is a balance, and we do have to be looking at all these things together as we go through. And then lastly, well, not quite last, but machine learning has been coming up a lot. Actually, last year, Aussie did a great talk on machine learning, and the big takeaway for me that I really I think has been prevalent in talks this workshop has been how do you validate and verify these systems, and like I said, just a quick reminder for those of you working on this still, go take a look at the SOTIF standard if you haven't already. And then quick plug, Aussie also has a white paper on some of our machine learning capabilities that you can go get from our website as well if you want to get a copy of that. Quick read, interesting. All right, so those are the examples I've given you so far. You might have noticed an omission. I didn't exactly omit it. I couldn't give it its own section because it doesn't fit in its own section. It really goes across all of these. And the architecture we choose there's a lot that we have to think about. NPR, I actually really like 7150's view of this. It actually has a lot of influence from Grady Booch, which I appreciate, and so I'll just give you the Grady Booch quote here from one of his works and highlight that its most significant measure is cost. Right. It's also up there in the NPR 7150. But that's not all NPR 7150 says. It does give you an enumeration of the various expectations for the architecture right after that quote, in fact. And everything from the components to the interfaces to valid states of operation, views and patterns and rules for how to use it. These are all about communicating. I'm highlighting the enumerated parts, but formalizing, defining and formalizing, maintains the rules, providing the stable structure for future groups. It's all about communicating that information, and you can't always have the why because you don't have time to go read the why every single time and have everybody learn that again. But it's really useful to be able to do that when you're not sure about what's going on or why you're doing it. So one last slide for you. Some of the factors that influence architecture, fairly straightforward. You know, the operational domains and capability needs. Obviously, safety and security are going to have a huge impact on your architecture. The performance and reusability. But there's also some lesser obvious impacts on architecture that are worth considering from a programmatic perspective. You know, your organizational structure, your project team, how it's organized, the prototypes that we're just using to validate, you know, the concept that management all of a sudden comes around and says, well, can't you just reuse that? The tools you use, like I mentioned, the Git, you know, using MBD products, using you know, C or assembly. I mean, all these things are choices that are going to have huge impacts on the rest of your architecture. So it's all related. And lastly, you know, just a quick nod to Eric Berger's presentation, our keynote on Tuesday. He had some really good examples of how budget impacts this. So, you know, just if you go back and look at his presentation, think about all those budget conversations he had, and how that impacts the architectures that you create and use. But in the end, it really is just about the sum of, you know, all the architect and design team's previous knowledge and experience. That's it.
Questions? Comments? Okay, thank you.